welcome to this HES-DVM tutorial. My name is Henry and I'll be walking you through the process of using Aldec's HES-DVM to emulate your designs. We'll first begin by talking a little bit about the design and the test bench. Here we have a diagram which provides a basic overview. We have our FIFO, which is our design under test. It's connected to a bus functional model. This bus functional model implements write and read functions to stimulate the FIFO. Both the BFM and DUT are instantiated by a top file, and the functions implemented on the hardware side are exported to the verification side in a simulator. A class is created with some wrappers for the functions defined in the BFM, and an object of that class is then created in the test bench, where the functions are ultimately called to stimulate the DUT. Now that we have a general idea of the structure, we can open DVM. We first need to navigate to a working project directory and then open DVM using the DVM command, which exists on my path. And we will first create a project by clicking on the file menu and then selecting new project. I'll name this DVM proj and use SCE-MI mode for function-based and pipes-based support. Co-Emulation mode is used for accelerating traditional test benches which do not utilize the SCE-MI standard. And we have ICE mode, which is in-circuit emulation mode. This mode is available where real devices for USB, Ethernet, SATA, and others can be connected to the emulator to drive real-world stimulus into the design. And then we have SCE-MI mode. SCE-MI mode is used for the lower-level SCE-MI macro-based interface. Finally, multi-engine mode is used for splitting the design into multiple subsystems to emulate each subsystem independently. Next, we can select the target emulation hardware. Various FPGA technologies are available to choose from. For this project, we will be targeting the Xilinx Vertex 7 series. And we can now choose our simulator. Many simulators are available. We'll choose Riviera Pro. Okay, after the project is created, a working library must be created. And the default settings here are fine. From here, design files are selected to be compiled into the library by clicking on Tools and Compile Files. Here we can select the 3 files we went over earlier in the diagram, and we'll go ahead and compile those. Now elaboration should be performed by right-clicking on the top level and selecting Elaborate. This dialog box allows you to assign specific parameters and generics to your top level. Now the emulation hardware should be designated by clicking on the Design tab, then Boards and Set Board. DVM will automatically detect the emulation hardware connected to the workstation. And next we'll run the HVD analyzer to set the debugging signals. This process must be completed in order to have signals available for viewing, which we'll choose the signals later. From here, we'll set the synthesis option from the synthesis menu. I'll go ahead and choose Vivado with parallel mode and 8 parallel tasks. And then we can go ahead and run synthesis from the synthesis menu by clicking Run/Stop Synthesis and Analysis. Once synthesis is complete, the top module can be added to the emulator by right-clicking on the top level and selecting Add Instance to Hardware. Now additional files need to be generated. I'll go ahead and click the Generate Files button and view the generated files on the left. One especially important file is the HES.XML configuration file. It contains a reference to the bit file, which will be generated after implementation. This HES.XML file will be used later by the simulator to access the bit file and program the FPGA. Now it's time for implementation, where the design will be placed and routed into the FPGA. And so we can do it in parallel or in serial. I'll go ahead and do it in parallel. We can view the status of each implementation phase down below and stop it if necessary. Now that implementation is finished, we can save the project and exit DVM. At this point, we can configure any signals we wish to view for debugging. We'll do this by using the hardware debugger utility provided with the DVM installation. First, we'll open up the HES-XML project file and choose probes. We can expand the hierarchy and then select the signals that we want to add. So we'll go ahead and choose a couple here. And then we'll check the enable debug option, save the project, and it's then time for our simulator to be opened. There are two modules which need to be initialized at the top level. The first is an AXSV sync module. This module is provided with DVM and forms the bridge between simulator and emulator. The other is the test bench. The test bench will perform a write loop and a read loop, as well as use the write data and read data functions from the BFM to stimulate the FIFO. And we can also see some display statements here, which will be outputting to the console as the test bench runs. I'll be using a script to initialize both modules, and we can see the script referencing the HES.xml file here, and the two top modules which I'll be initializing, as well as some overhead and housekeeping options for the vsim command. So I'll go ahead and run this script, and after it's finished, we can take a look at the simulation database file, which should show up shortly on the left-hand side. Let's go ahead and click on that. And in the hierarchy tab, we can see our hierarchy, our transactor, and our DUT. I'll go ahead and open up a waveform here and change the scale. And then start adding signals to the waveform. And here we can start to look at the values that we got from our emulation. Here's a read loop. And we can also look at the console. So you get the output from the console. And that's about it for this video. Thank you for watching. To evaluate Aldec's HES-DVM or any of our other products, please visit our website at aldec.com.